So today we're going to learn about asymptotes. We've talked about this before. It is a line a curve approaches but never touches. So if you look at the drawing on the right, there's a horizontal and a vertical asymptote. A hole we're not going to talk about as much. It's a break in a graph. And so method one for finding asymptotes is what you've already been doing. And what you do is you just graph the function. And then after you graph the function, you just look at it like we've been doing and figure out where you think the two dotted lines would be. However, that is not the most accurate of methods, so that's why I'm giving you a second method. So to find the vertical, what you do is you factor the denominator, and that could be with sign divide, the formulas, or GCF. And then after you do that, you set the factors equal to 0 and you solve them. And it's important to remember that vertical asymptotes are x equals, so I'm going to require you to write equations. Now for horizontal, it's different. What you have to do is you have to look at the degrees of the polynomials. So what a degree is it's the highest exponent. So if we're looking at the first case over here, the first case is when the degree of the polynomial on top is higher than the one on the bottom. So what that means is that if you look, the degree on the top is 5, and on the bottom the degree is 4. So 5 is bigger than 4, so it has a larger degree. And so what that means is that the answer will be none. So there are no horizontal asymptotes. You could graph it and there wouldn't be any. Now, the next case is when the degree in the polynomial on the top is lower than on the bottom. So in this case, there is no x on top. And so when there's no x up top, then we assume that the degree is 0. Okay? And on bottom, that has a degree of 1 that is assumed. And so since 0 is smaller than 1, the degree in the top is smaller. And so what that means is that the asymptote will always be at y equals 0. Now, when they are the same, so if you look at the degree on the top, the highest degree is 3. It doesn't matter that they have a 2 as well. The biggest one is 3. On the bottom, the highest is 3 as well. So what that means whenever you do have the same is you divide the leading coefficient. So what that means is coefficient is the leading number. So in this case, the leading numbers or 7 and 3. So that means that my asymptote would be at 7 over 3, 7/3. And so a way that you can remember this is that I had one of my tutors a long time ago thought this up, and I thought it was clever. If you have someone that was going to sit on top of you, if someone was sitting on top of you, and say someone bigger was going to sit on top of you, so the degree of the polynomial on top is bigger, so the person's bigger than you, then you would say, no! And then imagine that someone smaller sitting on top of you, so the degree on the top is lower than the bottom. You would say, oh, so 0. So hopefully you remember that. And then the last one you just got to remember. All right, so let's do a few examples. So for vertical, on the bottom of this, there is nothing to be factored. So what I do is I just set the bottom equal to 0 and I solve it. So I'm going to add 4 over. So when I solve just the bottom for x, I get 4. So the vertical asymptote is 4. And if you graph this on your calculator, you would see there would be the dotted line would go through 4. For horizontal, what I do is compare the exponents. So the exponent on the top is 1, and the exponent on the bottom is 1. So that means that they have the same exponents. What we do is we have to divide the leading numbers. So I'm going to divide the numbers. So it's 5 up top. And then on bottom, there is no leading number, so we just assume it's 1. So 5 over 1 are just 5. Example 2. This one doesn't have an equation, so sometimes they like to throw this at you at the SOL. So you have to decide where you think the lines would go, which we've already kind of done. So you just pick look at the 2 endpoints, and you pick the line that would go right in between them. Same, I look at my 2 endpoints, and I pick the line that would go right in between them. So when I am writing my things, I need to remember to write x equals for vertical and y equals for horizontal. So for vertical, the asymptote is going through right here at -2, and for horizontal, it's going through at -1. So another equation, I need to factor the bottom of this one. It is not factored for me, so -6 and -1, and so that is -3 and 2. So x minus 3, x plus 2. Now I have to take both of those separately and solve them. So I take x minus 3 and I set it equal to 0, and I set x plus 2 equal to 0. So this is going to have two asymptotes. So the first one, when I solve it, I get x equaling 3, and the second one I solve it, I get x equaling -2. Now whenever I look at the degrees of the polynomials, I'm looking at the original. So I've got a degree of 1 up top and a degree of 2 down bottom. So that means it is smaller on top. So if someone's smaller sitting on top of you, you go, oh. And so that means it would be y equals 0. For the last one, you need to GCF the bottom. So it has a GCF of x, and when I divide both of them by x, I'm left with x minus 1. So I need to set both the GCF, if it has an x in it, equal to 0. And I need to set what's inside equal to 0. If the GCF is just a number, you don't have to worry about it. It means nothing. But if it has an x, you need to set it equal to 0. So when I set this GCF equal to 0, it already was solved. So x equals 0 is the first vertical asymptote. The next one, I need to add over 1, so x equals 1. For horizontal, I compare my exponents. So on top, I have an exponent of 3. On the bottom, I have an exponent of 2. So since it's bigger, and if someone's bigger sitting on top of you, you say no. So it is none.